I'd like to introduce or explain better what's permutation. The topic ahead of us here says permutation and combination. And before I delve into the questions, I'd like to explain what permutation is and what combination is. Now, permutation is an ordered arrangement of items from a larger set. Now, it is given by this formula. For example, choosing R from N is given as N factorial over open bracket N minus R, then factorial. Now, what about combination? Combination is an ordered selection of items from a larger set. For example, now, selection of R from N is given as N factorial over N minus R factorial. Simply, I always tell students that permutation is about arrangement of objects, while combination is about what? Selection. These are two distinct distinctions between permutation and combination. Permutation is about arrangement, while combination is about selection. Do you understand that now? So let's take some questions. Question 1. In how many ways can 6 students be arranged? In how many ways can 6 students be arranged in a straight line for a photograph? Remember, I told you that permutation is about arrangements, all right? Why combination is about selection? Look at question 1. Is on what? Permutation of distinct objects. Permutation of what? Distinct objects. This is a straightforward question. In how many ways can 6 students be arranged in a straight line for a photograph? But before that, I would like to explain to you what factorial is. Factorial is a representation. Factorial is a representation. Factorial is the representation of numbers. Is the representation of numbers denoted as this. Representation of numbers denoted as this. Now, O factorial is 1. In that order, O factorial is what? 1. Then we have 1 factorial is what? 1. We have 2 factorial is given as what? 2 times 1, which is what? 2. Are we following me? So in that order, O factorial is 1, 1 factorial is what? 1, 2 factorial is what? 2. Then we have 3 factorial. In that order is what? 3 times 2 times 1 is 6. 4 factorial is what? 4 times 3 times 2 times 1. We give us what? 24. Then 5 factorial is what? You can see the order. 5 times 4 times 3 times 2 times 1. We give us what? 20 times 6, that's 120. So on and so forth. So in that order, so that's what factorial is all about. Now, in how many ways can 6 students be arranged in a straight line for a photograph? This permutation of distinct objects. 6 what? Students. So that's 6 what? Factorial. 6 factorial. This is permutation of distinct what? Objects. So 6 factorial. Can somebody tell me what is it going to give us? All right, so we have 6 times 5 times 4 times 3 times 2 times 1. So this is 30. 30 times 4 is 120. 120 times 6 is what? 720. That is the answer. And the correct option is what? C. This permutation of distinct objects. Now, question 2. In how many ways can the items of the word table be arranged? Remember, I told you arrangement of objects is talking about permutation, while selection of items or individual is about what? Combination. In how many ways can the letters of the word table? Now, before you solve this question, the word table, how many letters do we have in the word table? How many letters do we have there? We have about 1, 2, 3, 4, 5. The word table is 5 letters. 5 letters. So it's also permutation of distinct objects. So that's what 5 factorial will give us 5 times 4 times 3 times 2 times 1. So this is 20. 20 times 6 is as 120. 1 word, 120. Do you understand that? All right. Let's go to question 3 now. Question 3 says, in how many ways 3 students be selected from a group of 7 students to represent their school in a competition? Remember, this is about selection. And I told you that talks about what? Combination. In how many ways can 3 students be selected from a group of what? 7 students. So that is what? 3 from 7. 3 from 7, that is what? 7 combination 3. 7 combination 3. So remember I gave you that for combination, this is it. So that means 7 factorial over 7, n represents 7, y the r represent the 3. Selecting 3 from 7. So that's what 7 minus 3 is 4 factorial. Then there's a repetition r, which is 3. So what we're going to do is what? We are going to work this out, simplify in such a way that what? This, the one up, this, so we have 7 factorial is what? 7 times 6 factorial. Well, 4 factorial cancel 4 factorial here. So we have now what? 7 factorial over 4 factorial over 3 factorial. So we have 7 times 6 times 5 times 4 factorial over 4 factorial times 3 factorial. So 4 factorial cancels. The one up and the one down. Now we now have what? 7 times 6 times 5 over 3 factorial. 3 factorial is what? 6. So 3 factorial cancels 6 here. So we have 7 times 5 will give us 35. 7 times 5 will give us 35. So that's the answer. That's the answer. And the correct option there is what? B. All right. I hope you understand it. I hope you understand it. I hope you're following me. All right. Question 4, please take note of the question. 5 people are to be arranged in a row for a photograph. How many arrangements are there if the married couples insist on sitting next to each other? 5. 5. What's that number of people there? We have about 5. This permutation of indistinguishable objects. All right. 5 people are to be arranged in a row for a photograph. 5 people are to be arranged in a row for a photograph. How many arrangements are there if the married couple insist on sitting next to each other? We have about 5 people there. And 2 couples will be treated as one. They insist on sitting next to each other. All right. Now we have about 5 of them, total number of people there. We have about 5. Now 2 couples. Married couple. Will be treated as what? 1. Though they are 2, right? They'll be treated as what? 1. So how many do you have left here now? 5 minus 1 is what? 4. So the total possibility, total arrangements now, will now be 2 times 4 factorial. 2 times what? 4 factorial. Couple to 1. There are about 5 people. There are about 5 people. So we have 2, we have married couple. They are 2, a man and a woman. But in sitting arrangement, they will be arranged or they will be taken to be just 1. So 1 out of what? 5, we have 4 remaining. Okay? So factorial. So explaining about factorial. Factorial is the representation of numbers in words denoted as with that sign. Remember the definition I gave you about factorial. So 0 factorial is 1, 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is what? What's 4 factorial? Somebody tell us. So 2 times 24 will give us the total arrangement will be what? 48. 48. 48. That's the correct answer. Please listen to the question very well. Listen to the question, read the question very, very well. You have to be very careful about the question. It says, find the number of ways the word foot can be arranged. Find the number of ways the word foot, F-O-O-T, can be arranged. If the O's must always be words together. Remember the previous question we just solved now. The question we just solved. If the couple must sit together. All right? Remember, it just like the same question. But the first thing you have to take note of this question is the word food. How many letter word is it? The word food, how many letter word is it? So food is a 4-letter word. All right? Now the question says, please look up. The question says words that find the number of ways the word food can be arranged. If the zeros must always be words together. What it means is that the O's will be taken as what? 1. The O's will be taken as what? 1. Now the total letter for the word foot is what? 4. So the O's taken as 1, that's what? 1 out of what? 1 out of what? 3. 1 out of 4, that's what? 3 letters. So the arrangement now will now be what? The 1, because the O's, they are just 1 times 3 factorial. 1 times 3 what? Factorial. So that will be 1 times 3 factorial is what? 3 times 2 times 1, that's what? 6. 1 times 6 is what? 6. That's the correct answer. 1 times 3 factorial is what? 6. Because 3 factorial is 6. So 1 times 6 is what? 6. All right. Now look at question 6. Whenever you want to solve question in mathematics, you have to read the question carefully so that you know how to go about it. Now, question 6 says, a final examination of certain school requires that a student answer any 3 out of 5 questions. Any 3 out of what? 5 questions. In how many ways can this be done? We have a total of 3 questions. To answer 3 from there, we have about a total of 5 questions rather to answer 3. That is combination. 3 out of 5. 3 out of 5. 3 out of 5. Attempting 3 questions out of any 5 questions. So that is what? That is 3 from 5. Meaning 5 combination 3. 5 combination 3. A selection of 3 questions out of 5 questions. All right? That is 5 combination 3. 5 combination 3. So let's solve it now. Remember, I gave you that for combination is n factorial over n minus r factorial repeated. Now the n is what? 5. The r is what? 3. So we have 5 factorial all over what? 5 minus 3 factorial, 3 what? Factorial. All right? So we have now what? 5 factorial over what? 5 minus 3 factorial, then 3 factorial repeated. So we have what? 5 factorial over 5 minus 3 is what? 2 factorial, 3 factorial. So we have 3 factorial is the highest on the denominator side. So this 5 factorial will be what? Reduced to stop at 3 factorial. So we have what? 5 times 4 times 3 factorial over 2 factorial times what? 3 factorial. So 3 factorial cancel 3 factorial. We have 5 times 4 over 2 factorial. Somebody tell us, what is 2 factorial now? What is 2 factorial? 2 factorial is 2. So we have 5 times 4 over what? 2. 2 here 1, 2 in 4 is 2. So we have 5 times 2 over 1 is 10 over 1, which is what? 10 ways. 10 possibilities. All right? Like I said, if you are solving question, please read the question carefully before attempting it. Now look at question 7 now. In how many ways can 2 students be selected from a group of 5 students in a debating competition? Selection of 2 students from a total of 5 students in a debating competition. This also talks about combination, selection of object from a total number of objects given. All right. So that means we have selection of 2 from 5. 2 students from 5, a total number of 5 students. That is 5 combination 2. 5 combination 2, which is what? 5 factorial over what? open bracket 5 minus 2, close bracket 2 factorial, then 2 factorial. So we'll continue here. So we have 5 factorial over 5 minus 2 is what? 3 factorial, 2 what? Factorial. So we have on the denominator side, we have 3 factorial. Then on the numerator, what you have to do, we reduce it to stop at the 3 factorial. So 3 factorial times what? 2 factorial. So we have 3 factorial cancel 3 factorial. We have 5 times 4 over 2 factorial, which is 5 times 4 over 2 factorial is 2. 2 here 1, 2 here 2. So you have 5 times 2 over 1 is 10 over 1, which is what? 10. 10 is the answer. 10 is the correct answer. Now let me go again. Permutation is about arrangement of all the objects. From the definition I gave you, arrangement of objects in an ordered manner. Why combination is a selection of objects. If you look at the distinction between permutation and combination, permutation simply, the way I define it, is about arrangement of objects, while combination is about selection of objects. Please, do you understand it? Let's take a question. There's a question here that I want us to take here. There's a question I'd like us to take here. Let's take a question here. Let's take a question here. Let's take a question here. It says, how many ways can letters of the word mathematics be arranged? How many ways can letters of the word mathematics be what? Arranged? In how many ways can letters of the word mathematics be arranged? So this is permutation of indistinguishable words, objects. Permutation of indistinguishable words, objects. How many ways, in how many ways can the letters of the word mathematics be arranged? Mathematics. In how many ways can the letters of the word mathematics be arranged? The first thing, when you're told to find permutation of a word, the first thing you have to note is how many letter word makes up that, how many letters makes up that word. Now, in how many ways can the letters of the word mathematics be arranged? In how many ways can the letters of the word mathematics be arranged? So, how do you solve it? So, you need to first of all find how many letters are in the word mathematics. So, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, the word mathematics has about 11 letters. 11 letters. All right. Now, we have letters that are repeated. Let's look at the letters that are what? Repeated. We have the A, we have the what? We have the N being repeated. We also have letter what? A being what? Repeated. Also letter what? T being what? Repeated. All right. So remember, this is permutation of indistinguishable words, objects. So we have 11 letters making up the word mathematics. So that's 11 factorial all over mathematics. The word M. We have M appearing how many times here? 1, 2. 1, 2. So that's 2 factorial. Then the letters of the word, the letter A, how many times does it appear here? That's 2 also, 2 factorial. Then the letter T, how many times does it appear here? We have 2. Which other letters again? Which other letters again? E appears once. T appears, so I have written that I appears once, C appears once, S appears once. This permutation of indistinguishable words, objects. So in how many ways can letters of the word mathematics be words be arranged? So we have 11 factorial over 2 factorial in all will give us what? 2 times 2 times 2. That's 11 times 10 times 9 times 8 times 7 times 6. Let me write it here. 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over what? 8. So 8 cancels here. So let's multiply all this. Let's multiply them. So let's see now. 11 times 10 times 9 times 8 times 7. 11 times 10 times 9 times 7 times 6 times 5 times 24. 4 times 3 is 12. 12 times 6 is 24. So we have a total of 4 million rather, 989,600 ways. We are asked in how many ways can the letters of the word mathematics be what? Arranged. This is a permutation of indistinguishable words objects. Thank you. I'll see you in the next class.